Hello! Today we'd like to talk about solving two-step equations. When we solve two-step equations today, I want you to be mindful of how we solved one-step equations. They're so similar. The key today is to remember constant first. You have to tackle the constant first. All right, let's get started. Our vocabulary today is the same as it was with one step. Inverse operation. An inverse operation is an operation that undoes another. I made a note here that says, think big four. Remember, the big four are adding, subtracting, multiplying, and dividing. So addition undoes subtraction. Subtraction undoes addition. Multiplication undoes division, and division undoes multiplication. Just make a note of this right here. On your note sheet, I've got an explanation for solving two-step equations. We've already covered how to explain a one-step equation, and we talked in class about how it would be consistently explained every time, aside from a few fill-in-the-blank parts, like where you fill in the operation being performed, you fill in this inverse, and so forth. So please, going forward, use that explanation for solving a two-step equation, just like we have practiced in class. As far as the notes go, you don't have to write anything in there. Let's go ahead and apply that explanation to solving example 1. 3x plus 5 equals 20. In order to isolate the variable, I must first identify the constant. The constant in this two-step equation is 5. Remember, a constant is a number with no variable. The inverse operation is subtraction. So first, I will subtract by 5 on both sides of the equation. That leaves me with 3x equals 15. The operation being performed on the variable is multiplication. The inverse operation is division. So secondly, I will divide by 3 on both sides of the equation. That leaves me with x equals 5. Now that my variable is isolated, my solution is 5. Remember, you can check yourself for accuracy by substituting that point back in to your original equation. So if I said 3 times 5 plus 5 equals 20, 3 times 5 is 15, and 15 plus 5 equals 20. Clearly, x equals 5. Example 2, in order to isolate the variable, I must first identify the constant. The constant in this two-step equation is -1. The inverse operation is addition, therefore I will add 1 to both sides. That leaves me with 1/4 m equals 12. The operation being performed on the variable is multiplication. The inverse operation is division, or I can multiply by its reciprocal. I will multiply by 4 over 1 on both sides. That leaves me with m equals 48. Now that my variable is isolated, my solution is 48. In order to isolate the variable, we must first identify the constant. The constant in this two-step equation is kind of tricky because you're adding a negative number. So negative 5 is the constant, and because it's negative, the inverse operation would be to add 5 to get it to 0. So if I add 5 to both sides, I'm going to be left with x divided by 4 equals 20. The operation being performed on the variable x is division. Therefore, I should multiply both sides of the equation by 4. This leaves me with x equals 80. Since my variable is now isolated, my solution is 80. Example 4 is a little tricky because it entails some distributing and some division before you have a two-step equation. So first, we need to distribute this 4 through the parentheses. That's going to give us 4x plus 12 divided by 2 equals 10. And if I divide every term in the numerator by its denominator, that's going to leave me with 2x plus 6 equals 10. So in order to isolate my variable, I must first identify the constant. And the constant in this case is 6, positive 6. So the inverse operation is to subtract 6 from both sides. That leaves me with 2x equals 4. The operation being performed on the variable is multiplication, so I must divide both sides by 2. I'll get x equals 2. Since my variable is isolated, my solution is 2. This would be a great problem to go back and check yourself when you're finished to make sure that you have the correct answer. If I plug a 2 in, substitute 2 for x, 2 plus 3 is 5. And 5 times 4 is 20, so I have 20 divided by 2 equals 10, and 20 divided by 2 is 10. So x equals 2. Example 5 is a word problem. Rebecca set up a lemonade stand. She borrowed $3 from her mother to purchase her supplies. If she charges 50 cents per glass of lemonade she sells, when will she have made $20 in profit? Write an equation to model this situation and solve. So let's talk about key information first. She borrowed $3 from her mother, and she charges 50 cents per glass. So if we let x represent the number of glasses of lemonade sold, and we want to know when she has made 20 in profit, we know that something is going to equal 20. So 50 cents per glass is going to be 50 cents times x, but we have to subtract $3 because she's got to pay her mom back before she can make profit. So this is the equation that we have now written to model this situation. In order to solve this, we must first identify the constant. The constant in this problem is negative 3. So the inverse operation would be to add 3 to both sides. That leaves us with 50 cents times the amount of glasses sold equals $23. So we really need to make $23 to make that $20 profit margin. The operation being performed on the variable is multiplication, so we need to divide both sides by 50 cents. That leaves us with x equals 46. So now that my variable is isolated, my solution is 46, which means Rebecca needs to sell 46 glasses of lemonade in order to make $20 in profit. On your step-by-step notes, I've given you 3 practice problems for you to try. I'd like for you to pause your video and try the next 3 practice problems. When you've got those 3 completed, come back and hit play. All right, Marla's collecting change for the Firefighter Foundation. She begins her day with the $2.50 that her mother donated. She collects on average 75 cents from each car that stops to donate. If she finishes her day with $18.25, how many cars donated an average of 75 cents? If you let X be the number of cars that donate an average of 75 cents, you can write the equation 75 cents times X plus 250 equals 18.25. After you've identified the constant and applied its inverse operation, you'll get 75 cents X equals $15.75. Dividing by 75 cents on both sides of the equation tells you that your solution is 21. This means that Marla collected an average of 75 cents from 21 cars. You try problem number 2. If we first identify the constant, we'll see that the constant is -5. So if we apply the inverse of addition and add 5 to both sides, we get 2/5 m equals 10. Since we're multiplying by a fraction, you can eliminate the fraction by multiplying by its reciprocal. So if I multiply both sides of the equation by 5 halves, I get m equals 50 halves, and 50 divided by 2 is 25. So, once we've isolated the variable, we know our solution is 25. You try problem number 3 is another example where you have to distribute and divide before you have a 2-step equation. So once I distribute the 6 to every term inside the parentheses, I get 6x plus 18 divided by 3 equals 5. Then if I divide every term in the numerator by its denominator, I get 2x plus 6 equals 5. So I've identified the constant as a positive 6, so I subtracted 6 from both sides, and that left me with 2x equals -1. The operation being performed on the variable x is multiplication, so I divided both sides by 2, and that leaves me with x equals -1/2. This is the first time you've had a fraction as your solution, but remember, any rational number can be your solution. This concludes our video. Make sure your step-by-step notes are complete. Then I'd like for you to summarize how to solve a 2-step equation. And lastly, I'd like for you to take your Edmodo quiz. Tomorrow in class, we'll work on applying 2-step expressions and equations, and hopefully we can take what we've learned to the next level. Best of luck.